Testing. Good morning, class. I'm hoping to have the written part of this video just a little bit clearer than what I have in the past. I'm kind of learning the medium as well. Hopefully it'll begin to make more sense to you. I would like to review one here today of a two-tailed test. So what you see up here is an example again of a two-tailed test. So we're going to review that, and then we're going to look at a bunch of single-tailed tests as well as some computer printouts. So I'm hoping that it will be fine. At the end of this section, I'll be assigning 9.2. It'll be due this Friday, April 3. And hopefully that'll all make sense to you as well. We have a claim here that the average retail price of their cookbook is $35. The word is $35 is especially screaming at us that it's a two-tailed test. We're checking this claim. We're going to run the test at a 2% level of significance. That's meaning alpha is 2%. 2% is kind of unusual. Usually they go with 1, 5, or 10, but I wanted to do a couple of these today where we have an unusual alpha level. They give us a random sample of 50. The retail price is $32.97. Is that reasonably close to 35? Or is this price so far away from 35 that we have mathematical evidence that 35 can no longer be true? We're going to run both the critical value test as well as a p-value test. So on the left side, we're going to go a critical value test. On the right side, I'm going to go with a p-value test. Most of the examples today, I'm going to be doing both. But again, I want to remind you, on your test, I will tell you either to go with just the critical value, or I'll tell you just go with the p-value, in which case you must follow those directions. You would not be doing both. If I don't specify which one you have to use on the test, then you could have your choice and I would accept either one. You will never be asked to do both on a test like I'm doing them here. I'm doing both just to make you more and more comfortable with those. This, as we mentioned, is a two-tailed test because of the word is 35. So step number one, I'm going to list my null hypothesis and my alternative hypothesis. H sub A is alternative, H sub 0 is the null. Two-tailed tests, we recall, are very easy because the null is always the mean equals, and the alternative is always the mean does not equal for two-tailed. Single-tailed tests, which we're going to look at a lot here today after this example, is a little more difficult to determine which one is which. But in this case, we're looking at, does it equal 35? Is it 35? So 35 is the mean number that we're looking in both of those cases. It'll be exactly the same for a p-tailed test. The null would be the mean is equal to 35. The alternative would be that the mean does not equal 35. The same for both of them. Step number two, we're going to list our alpha level. As I mentioned, this one is just a little bit more difficult to come up with that 2%. Because it's an unusual alpha level. We also had a sample of 50, which is our second component in step two. Because 50 is more than 30, I'm going to be using the z-stat. And now for a critical value, we need our rejection region. I'm going to put that rejection region below here. RR for rejection region. Well, that 2% needs to be split on both tails. What do I mean by that? I mean this, that on the normal curve, which I'm testing at 35, this 2% has to be split on both tails. So both tails have a 1%. That leaves 49% in the middle. So I need to look up the 49 because the chart is built from the middle out and find out what is that z-score. So if I look up 49, the closest one is right here. It's at a z-score of 2.33. That means that z-score, that line in the sand, is at a z of 2.33 and a negative 2.33. So my rejection region is going to be if z goes to the left of this negative number, 2.33, or if z goes to the right of the positive number. So in other words, my rejection region will be z is less than that negative 2.33, or it's going to go over the positive. Z is greater than 2.33. I have two parts to the rejection region because it's a two-tailed test. Those z-scores are my line in the sand. If my sample is somewhere in the middle here, that's reasonably close to 35. Then I would have insufficient evidence to doubt 35. I would continue to assume that it's equal to 35. But if my sample goes over this line to the left, or if my sample goes over this line in the sand to the right, then I've got sufficient evidence to say 35 is not true. I would have sufficient evidence to reject 35 and conclude that it doesn't equal 35. The p-value test will list the same alpha level. It will list the same sample size and the same statistic, z. And the reason we're listing that z-stat is because, I missed that, the n was greater than 30, it was 50. So now number 3, step 3. I need to calculate my z-score. It's going to be the sample mean minus the hypothesized mean, that's the number up here, divided by the standard deviation divided by the square root of n. So plugging in my numbers, my sample mean, average price from the sample was $32.97. That's my X bar. $32.97 minus the hypothesized mean, 35, divided by my standard deviation, which was 12.87, divided by the square root of my sample size, 50. When I calculate that out, I round it off to a negative 1.12. Didn't write that very well. Let me do that again. A negative 1.12 when it's rounded off. Make sure, again, you can get from this whole big expression to that value. It's a calculator exercise, but you're going to have to be able to do that on both your assignment as well as certainly on your test. Looking at this negative 1.12, first of all, it's negative. So I ignore the positive line in the sand. Because it's negative, I'm going to look at this negative line in the sand. A negative 1.12 actually shows up somewhere about in here. It did not go over the line in the sand. It was within reasonable variance of the 35. Because it did not go over the line in the sand, I have insufficient evidence to reject 35. I've got to continue to assume 35 is a reasonable assumption for the mean. So that's what I'm going to write here in step number 4. Z equal to a negative 1.12 is insufficient evidence to reject our null. What we mean by that is it's insufficient evidence to reject the mean is 35. So we continue to assume, we don't prove now, we continue to assume the mean price of their cookbook is still $35. Some key words that I'll be looking for on your test. Insufficient is a key word. Whenever we have insufficient, we always continue to assume is another key phrase. Those must be in there for you to get full credit on your test. These types of hypothesis tests, when done on your test, because it's such a long answer, these are going to be worth anywhere from 8 to 14, 15 points apiece. So it's crucial that you have all the steps and you number them. For example, I mentioned this before, but if I leave off the numbers, I'm going to lose points. If I leave off n is equal to 50 right here, I would lose points. If I don't put the rejection region down, I would lose points. Those are all very key components in the entire test. If I go to the p-value test, I'm going to find the same z. I would write out that same formula. But if you don't mind, for just purpose of time, I'm going to go right from z all the way through this formula to a negative 1.12. You would actually show the formula, etc. But now I'm going to look for the p-value of this test. Because it's two-tailed, I'm going to double whatever I get on one of the tails. What do I mean by that? Well, in this case, if you recall, we got a negative 1.12. That's a z-score right over here. I need to find the probability of this tail and double it, because I'm looking for basically the probability that it's that far away from the mean. So I need to find that one tail and double it for my p-value. That is why I have a 2 here. When finding that, I need to find, first of all, the middle value of a 1.12. Going to my chart, 1.12, that middle value is 36.86. That's from the middle out. So that means from the middle out is 36.86. This tail then is 0.5 minus 36.86, and that's what's going to go in there, and I need to double it. So 0.5 minus 0.3686 is where I'm going to get that from. When I do that, that's going to be a p-value after you double it. It's going to be 0.3085 when you do those calculations. I take this p-value now and I compare it to the alpha level. If this p-value is less than the alpha, it means I have sufficient evidence to reject the 35. If this p-value is not less than alpha, which it's not in this case, then I have insufficient evidence. It's going to be the exact same conclusion that I had over here. It's just that here we're looking at the probability compared to alpha. Here we're looking at the z-score compared to the rejection region. They will always, provided you have the same alpha level, they will always give you the exact same conclusions. We just start off by saying p is equal to 0.3085 is insufficient evidence. Basically exactly what I write over here. And that would be the answer, or the second test, the p-value test. This was a two-tailed test, which is why we had equal and unequal. We were looking at whether it went either direction. Next, we're going to start looking at some now that are single-tailed test. Here's an example. We again started these, just the null and alternative hypothesis, a few lessons ago, but now we're going to run the entire test. Let's just review what it says. Rainer & Sons have been advertising. They hope that the result of the advertising is to increase the average weekly sales above, not is, but above. That word above is screaming at me, single-tailed test, above 7880. So they took a sample of 36 weeks, and it showed a mean of 8,000. Well, 8,000 is above the previous historical mean, but is it enough above that it gives me evidence that the advertising has been effective? That's what we really want to know. Even though it's above, is this within reasonable variance, meaning I don't have evidence that it's increased, or is this 8,000 so much bigger than 7,880 that it gives me sufficient evidence, mathematical evidence, to say the 7880 is no longer true, the advertising has been effective? That's what the test is trying to show. That's what an advertising agency would want to show a particular customer. They want us to, again, go both critical value as well as p-value. So I'm going to do the same thing I've been doing, put the critical value on the left, and again, put the p-value on the right. We start off by listing our null and alternative. This is now typically going to be a little bit tougher because it's a single tail. If you recall, in our elements of the hypothesis test, for a single tail test, we make the alternative what I'm trying to show. Okay? I'm trying to show is that the advertising has paid off. What I'm trying to show is that the mean is now above 7880. Because that's what I'm desiring to show, I want the mean to be greater than 7880. That's my alternative. I make my alternative what I want to show. The null then is the opposite. So the opposite of greater than is less than or equal to. the p-value would have exactly the same thing. Next, I list my alpha level. They gave it to us at 1%. If they hadn't given us any, we would have gone with the default, which is always 5%. But they gave me one. It's a pretty serious one. I have to show with 99% certainty that their advertising is paid off. That's going to be hard to do. It would be the same over there. Next, I list my sample size. It's a sample of 36, which is more than 30. That means I'll be using a z-stat. Step number 3, I'm going to excuse me, I forgot. I got to first get my rejection region. That rejection region, you remember, for 1%, it means that my from the middle out section is 49%. That means that that z-score, that line in the sand, is 2.33. This is from the previous one, but my line in the sand is 2.33. It'll be on the right side because I'm looking in this example to see if it's gotten greater, if it's increased our sales. So I'm wondering, is my z-score going to go over a positive 2.33? That might have been confusing, but z would have to be greater than a positive 2.33. This is typically a challenging part for a lot of students, so I'm just going to draw this once right here below. You wouldn't need this drawing, but it's to try and help you understand what we're testing. I'm testing against the 7880. I want to see if my sample goes far enough more that it goes over this line. This line said it's got to be in a 1% probability or more. We looked up the 0.499 in the chart. Again, it came from 0.499, 2.3. That means this z-score is 2.33. If my sample indicates that it's gone over that line, I have enough evidence to reject the null and conclude that it's increased. The advertising is paid off. If my sample does not go that far, we say it's within reasonable variance. We don't have evidence to doubt 7880 is still true. Because it would be within reasonable variance, we would continue to assume 7880. We would have insufficient evidence. That's what's actually going on here. So now, step number 3. I calculate my z. Again, it's the mean from the sample minus our hypothesized mean, standard deviation, divided by the square root of n. My sample mean, the sample mean was 8,023, minus my hypothesized mean, 7,880, divided by the standard deviation, which was 1733, divided by the square root of 36. Again, when you calculate that all out, it turns out to be, to find it here a moment, 0.50 it rounds off to. 0.50. Well, taking a look at our chart again, 0.5 is not going to be over the line. 0.5 is about right here. It's within reasonable variance. It would be insufficient evidence for me to doubt that. So that becomes my conclusion. 4 is Z is equal to 0.5. 0 is insufficient evidence to reject, insufficient to reject my null hypothesis, and thus we continue to assume the mean weekly sales are still at the 7,880. And I'm going to put this with it because this is kind of significant to the problem. What are we going to do about our decision towards this heavily advertising? We've done that for 36 weeks, and I have insufficient evidence to doubt the historical 7880. Because I have insufficient evidence, I really have no evidence that the advertising has paid off. And we have no evidence the advertising has paid off. Key phrases: insufficient evidence, continue to assume. Those are key phrases that we must have. Going over to the p-value, I would have listed my formula just like I did here. I would have listed the substitution, and I would have made the conclusion. Again, I want to emphasize, make sure you can get from this substitution to the actual value. The p-value of this test now, 0.5. Well, if you look at 0.5 in your chart, I'm trying to find this p-value. Notice this time, it's really 1 times that amount. Because it's a single-tailed, I don't have 2 here like I did last time. It's a single tail, so it's 1 times that 1 tail. What is it going to be for 0.5? Well, I would go to 0.5, which is right here, 0.50. It's 1915 in that column. So the tail is 0.5 minus that 1915. That's 0.5 here minus the 1950. That p-value then turns out to be 0.3085. 0.3085. We take that p-value, we compare it to our alpha. If it's less than alpha, we have significant evidence and we reject the null. We would say the advertising is paid off. But in this case, 0.30 is not less than 0.01. I have insufficient evidence, so I do not reject the null. I continue to assume that the mean sales are still at 7880. So my step number 4 would start off P equal to 0.3085. I would have that same phrase, insufficient, just like I had over here, and the rest would be exactly the same. That was an example of a single-tailed test, and I had insufficient evidence in that case. Excuse me. I'm sorry, I got one part left to do here. If this sample mean was 7,080, that would have produced a z-score of a negative 277. What would that have told us? What would we have wondered about that in that scenario? I hope you see that this would be a strong indication, very strong indication, that the advertising had not paid off. This mean would have been well below the 7880. It would have had a z-score way over here, negative 2.77. There is no way I would have said the advertising paid off. And in fact, we might have had evidence to say it actually hurt us, that we shouldn't have advertised at all. We're not going to run that test, just saying what happens if that would have. Take a look at now another example. This particular one, we're trying to market to the younger and younger age groups. The article suggested that the mean age of the consumer had fallen below, there's a key word, below is screaming at me single-tailed, below 3440. That's what it's been in the last few years. So we take a sample, in this case, pretty large sample. We got 33.2. 33.2 is less than the 34, historical 34, but is it enough less that we have evidence that it has fallen below? We have an unusual alpha level. They want us again to go both critical value and p-value. So I'm going to again do both. Critical value and p-value. So here we go. Step number one. Got to find my null. And I got to find my alternative. The alternative we typically do first. It's what we want to show. We want to show that it's fallen below. That would be less than 34. So my mean is less than 34.4. The null is the opposite. It would be greater than or equal to 34.4. Same for the p-value. Step number two, got an unusual alpha level again. Alpha is equal to 0.04. Over here, same thing, alpha equal to 0.04. Sample size was 1,000. Very large sample, which means I'm going to be using a z statistic. N equal to 1,000. What would be that? Forgot 1,000 there. N equal to 1,000. Z stat. Step number two, I need to get the rejection region. Again, this involves understanding what direction we're going in. This is kind of crucial. Am I going to be listing a negative Z or a positive Z here? It's a very common place to make an error. You don't need this drawing, but some of you might want to put it just on the side in your margin. We're testing against 34.4. Here's crucial now. Because I'm hoping to show that it's less than, my line in the sand is on the left side, less than. Common mistake is people would draw it over here. If it were two-tailed, I would have it on both sides, but this is a single-tailed, so I only have it on one side. My Z must be less than that line in the sand, that Z-score. That Z-score, my line in the sand, will be for 0.04, and that means this is 0.46. So I'm going to find 0.46 in my chart and find that Z-score. 0.46, actually I have it right over here. The closest one to 0.46 is that one, 0.4599. Its Z-score is 1.75. That's the Z-score that I'm putting right here, 1.75. It's on the left side, so it's negative. If my Z goes past that, if my Z is less than that number, less than a negative 1.75, then I would have sufficient evidence to reject. I go to my step 3. I calculate the Z-score. Sample mean minus hypothesized mean, S over the square root of n. The sample mean was 33.2. Hypothesized mean was 34.4. Standard deviation was 9.4. Divided by square root of a pretty large sample. Turns out that that Z-score is a negative 4.04. That is off the chart. That didn't just go past this line in the sand. The negative 4.404 is way over here. You will occasionally get really, really weird Z-scores. You might even get a negative 15 or a positive 20 sometimes. That basically means it's off the chart, okay? There is no doubt we have enough evidence to reject it. There is no doubt it is now below 34.4. This went into my rejection region, which is why I'm rejecting the null. It's in the rejection region, the RR. So I list Z equal to a negative 4.04. Last time we had insufficient. This time it is sufficient evidence. To reject the null. Now notice I'm not continuing to assume, but I am going to now conclude. This is a much stronger statement. I'm not continuing to assume the null. I am going to conclude that the mean consumer age is now less than 34.4 years. Some key phrasing in there. Sufficient always goes with now conclude. Remember the last example, it was insufficient, went with continue to assume. Sufficient here always goes with now conclude. Step number 3, over here, I would have listed the same formula, same substitutions, got the same value. My p-value would have been 0.1, it's single-tailed. Now this might be a little bit hard to understand, but because it's so far over, all of from the middle out here for this Z-score, I've used all the part of the tail. I've used all 0.5, so it approximates 0. I compare that p-value to my alpha. If it's less than, which it is, I have sufficient evidence. I conclude the alternative. If this had been, say, 0.07, would not have been less than. But these two should produce the same values. So P equal to 0 is sufficient evidence, and the rest is right over here. Make sure when you're doing this on your assignment, and certainly when you're on your test, that you are writing this all out. This is a paragraph form, okay? And this last part is in what we say context of the problem, okay? So we understand what we have actually shown in this test. Another example. A recent advertisement claims the average amount of property and marine insurance written by Atlantic Mutual is greater than that number. Greater than is screaming at me, single-tailed test. It didn't say it is 325,000. It's greater than that. That's why we're saying it's a single-tailed test. We want to run the test to see if there's evidence that the claim is valid. We're not trying to refute the claim, we're trying to support it. So, again, I have my critical value test, and I have a p-value test. On your assignment, you will be asked to do just one or the other. I have to list the null and the alternative. The alternative is what I'm trying to show. I'm trying to show that it's greater than 325. So that's my alternative, greater than 325, 500. The null must be the opposite. Opposite of greater than would be less than or equal to 325,500. If they had said greater than or equal to, I would have put greater than or equal to here and just less than there. Usually they don't. They usually have the equality over here, but once in a while you'll see that written the other way. The one over here will be exactly the same. For just sake of time, can I write the same? Meaning it's exactly what I wrote right there. Step number 2, list my alpha level. I'm going to go with what the problem said. I'm going to ignore this second statement here. So I'm ignoring the second statement. Well, you know what? Let's do as the problem asked. We're going to do the critical value up here with the 5%. And this time, I'm going to use the multiple alpha claims with the p-value. So for the critical value, I'm just using the 5%. I had a sample size of 40, which meant I had a z-stat. I have an alpha level of 5%, so my rejection region, again, that drawing, I'm testing against 325,500. Because I'm trying to show that it's greater than, my rejection region is on the right side, greater than 325,000. This single-tailed inequality sign always tells you, do I draw it on the right or do I draw it on the left? Had this been less than, my rejection region would have been over here. Because it's greater than, it's on the right side. My rejection region is going to be that tail. 5%, because it's a single tail, all 5% is in that tail. If it were two-tailed, I would have split it up, but it's not. That means 0.45 is in here. This takes us back to, you remember, 90% confidence, doubled 45, 5 on each side. 90% confidence would have given me a, I'll find it here a moment yet, I'm sorry, 1.645, and you might have remembered that from your confidence intervals. 1.645 is my rejection region. If I go over that number, that's a positive number, 1.645. If Z gets to be more than that, I'm in that rejection region. I've gone over the line. I'll stay with this one first and complete it off. I calculate my Z, X bar minus the mean, S over the square root of N. The sample was 330,000 minus the hypothesized mean, 325.5, divided by standard deviation, which was 12,300, divided by the square root, my sample size, 40. Turns out if I've done all my calculations correctly, turns out to be 2.314. Well, if you look at your rejection region, if Z was more than 1.6, you would have sufficient evidence to reject. But our Z is not. Our Z is. 2.3 is greater than the 1.645. Basically, that 2.3 went over here someplace. It's far enough to the right that I now believe this number is no longer true. It's far enough to the right that I believe it's greater than that number. That's going to be my conclusion then. So step number 4. Z is equal to 2.314 is sufficient evidence to reject our null and now remember sufficient goes with we can conclude. We conclude. I'm concluding this hypothesis, but I want it in context. So I'm going to conclude the average amount of property insurance is greater than 325,000. The average amount of property insurance is now greater than 325,500 per month. This time I didn't do the p-value right away because the critical value wanted us to just go with 5%. P-value wanted me to list all of these. So step number 2, I'm going to list multiple levels of P. 10%, 5, and 1. I have the same sample, 40, which means the same stat. I don't need rejection points. I would find my Z just like I did here. It turned out to be 2.314. Well, that 2.314, you look over here, is, as I mentioned, to the right. What actually is the z-score? Well, I have to find, I'm going to draw it here again, 2.314 from this right here. This is my p-value. It's basically the probability that it's that far greater than our mean. The probability that it's that far to the right. So I have to look for 2.31 and find this probability. So if I do that, 2.31 is 4896. It's 2.31, 4896. This p-value is 0.5 minus the 4896. It's only on one tail, so my p is going to be 1, excuse me, not 0.1, 1 times 0.5 minus 4896. That turns out to be, in this case, gotta find it here a moment, turns out to be 0.0104. Notice that that is not less than 10%. It is not less than 5%. It is not even less than 1%. I don't have sufficient evidence at any of the alphas. So I apologize. I have made that wrong. Listen carefully, I'm going to correct that. I was going the wrong way. P equal to 0.01, would everybody agree? It is less than 5%. It is not less than 1%. P equal to 0.01 is sufficient evidence at 5%. It's obviously sufficient at 10%, but I use the most unlikely to give it a stronger conclusion. P equal to 0.0104 is less than 5%. It's not less than 1. So it is sufficient. Watch how I'm going to write this now. Sufficient evidence at, here's a key phrase in this particular one, at, I have to list the alpha that it works, at 0.05. That's my strongest statement I can make. I recognize that it's not sufficient at 1, but if it's not sufficient, then I have to make a weaker concluding statement. So I want it to be sufficient at whatever alpha I can claim it at, in this case 5%. So I'm saying it's sufficient evidence at 5% to reject the null, and basically it's everything else is the same. I think I'm going to, because of time now, go towards some examples that have a computer printout. Computer printouts make it easier for us. Before I do one of those, I would like to just remind you of some phrases that you sometimes have written in the problem. Alpha at 10% means some evidence. So sometimes the problem might say, do we have some evidence in favor of an alternative hypothesis? When they use that phrase, some evidence, they're basically saying, set alpha to be 10%. If the problem would say something like, do I have strong evidence in favor of some alternative hypothesis? That would be like saying, set alpha to be 5%. Very strong evidence, 1%. Extremely strong, it would be in the medical field, 0.001. Okay? Let's take an example now that has a computer printout. Okay? Chuck Cash is a personnel manager. From a brief examination of these records, Chuck feels the employees have an average of more than, there's a key phrase that's screaming at us, single-tailed test, more than 31,000 in their retirement accounts. They sample 100, find the mean is 31,366, which of course is more than that. Is that far enough that I have mathematical evidence to say that it is now more than? They want me to run the hypothesis test at a p-value. Whenever you have these kind of outputs, some computer output, p-values are usually easier to run because they give you the p-value right in the chart. You don't have to go to your normal distribution chart to find it. You also don't have to use the formula to get your z. They usually give it to you. Don't be totally alarmed by this. This is used at a different level. Standard deviation is given to you. The mean of the sample, here's my sample number, 100 in the sample. Notice that that 31,366 is the sample mean. Let's run the test using a p-value test. So this is a p-value test all the way. Here's something else that's nice about the computer printout. They're telling you what the null, equal, and the alternative, greater than or equal to. Some of you might have noticed that they didn't go less than or equal to here, the opposite of the alternative. You will be allowed to put equal here or less than or equal to. We would have accepted either one. The reason we can accept either one there is the following. We're trying to show that it's greater than. This one is the most important one, the alternative. It's what we're trying to show. So don't be alarmed if they go equal or less than or equal. I would accept either one at the test. Step number 2, going to pick up the pace here. We've done this often enough. They want me to test at multiple alpha levels. So alpha equal to 0.01, alpha equal to 0.02, alpha equal to 0.05. Sample size was 100. Z-stat. Notice now I'm just going to literally write out my Z. It is 1.93. I take it right off of that. I don't have to do the calculations. Don't have to show the formula. Just write it right out. And I can also write out my p-value immediately, 0.0268. Would everybody agree that this 0.026 is not less than 1%? It's not less than 2%, but it is less than 5. So I'm going to use that to make the strongest argument I can at the end. So number 4, p equal to 0.0268 is sufficient evidence. Whenever I have multiple levels, though, notice I have to do this at alpha equal to 0.05. Not only do I need sufficient, but this amount here is crucial, because otherwise I wouldn't know if I'm talking about sufficient at 1%, 2%, or 5. I have to list which one. So it's sufficient evidence to reject the null. And now conclude. The mean, here we go now. What am I concluding? The mean amount in the retirement accounts. The mean amount in the retirement accounts is greater than, I'm running out of space, sorry, greater than the 31,000. Like you to notice, when you have the computer printout, they give you all the calculations. You just have to put it into the form of a hypothesis test. Okay, I want to say that again. Whenever they give you a computer form, you just need to put it in the hypothesis test form. It's basically putting all the details in the argument. This hypothesis test form is a worldwide form accepted. That's why we want it in a specific order and where we're saying very specific things. Sufficient goes with now conclude. Okay? Our time is kind of running out, so I'm just going to show a few more forms here. Here's an Excel form. Notice they didn't give me the size of the sample. I would have to get that from the problem. N was 42. But notice they did give me the z-stat, and they did give me the p-value. They also gave me the null and alternative. It was a two-tailed test, agreed, because I have unequal and I have greater than. Remember with a two-tailed test, our p-value was always 2 times 0.5 minus something because it was two-tailed. Well, this p-value has already done that multiplication by 2. So this p-value would have turned out to be 1336. Okay, obviously not less than the alpha level at 7%. I would have had insufficient evidence. I would have had to continue to assume that the mean was 115,000. An SAS output. They gave me the sample size, they gave me the standard deviation sample mean, they gave me the z-value, they gave me the probability. I would have to just write out all the information in the form for a hypothesis test. Again, probability of 18%. This one would not have been less than 5. It would have been insufficient evidence. I would have had to continue to assume the null hypothesis. Let's just make sure we know what that null would have been here. Let's go back through here. It needs to average 18. That is screaming at me two-tailed test. They didn't list it here, but I would have had for step number 1, two-tailed test is always where the alternative is not equal, in this case 18 ounces, and where that the null does equal 18 ounces. This was a two-tailed test. The probability would have already been multiplied by 2. Everything else now just needs to be put in there. That concludes our lesson for today. I know it was a little bit longer, but I tried to do a lot of examples. It is very, very important that you are comfortable doing both a critical value test and a p-value test. You should be able to do those for both a single-tailed hypothesis test or a two-tailed hypothesis test. Again, try to go back, look at all the details that I put in each one of those. You will get some problems on your assignment where they'll give you computer printouts, and when that happens, you're thinking, thank you, they did a lot of work for me. Other times where you got to do all the calculations yourself. Again, assigning 9.2, assigned this Monday. It'll be due this coming Friday, which I believe is about April 3. Have a good day.